Hi, everybody. Welcome to the new chapter. We're going to start chapter 7 here, working with exponents. You'll see a lot of overlap between the physics and the algebra this chapter. I want to look at our learning goals for today. We're going to cover the first two learning goals. So this one here, number 1 and number 2 are what we're going to focus on today. And then tomorrow we'll focus on number 3. Your job today is to take notes, and then you'll be uploading a picture of the notes, and then there'll be one other learning task to go with this. So our first goal is to determine what an exponent of 0 means, and then also to determine what a negative exponent means. So there'll be some vocabulary that I want you to know. First word that we want to be familiar with is what's called the exponent. Most of you have heard this. We've used it before. Exponent is just the superscript. Superscript means it's written up above. Superscript, that tells how many times the base gets multiplied by itself. All right, and then the base is actually the part that gets multiplied. So the base will be the part that gets multiplied by itself. All right, so to help you figure that out, we're going to do a little bit of practice. So you'll answer the questions first and, see how it goes, and then we'll go through them. So on number 1, we want you to put a box around the exponent and then underline the base. So here I'm going to underline 2 and put a box around 4. So this would very simply, this would just mean 2 times itself 4 times. All right. On the next one, the base is what's in the parentheses, and the exponent is 3. So my base is -7, and the exponent is 3. So that would mean we're taking -7 times itself 3 times. On the next one, you have to be careful because it looks a lot like the previous one, but the difference is if there are no parentheses, you just assume that whatever's directly in front of it is the base, but it does not include the sign unless the sign is grouped with it. So here the base is not -7. Here the base is 7, and your exponent is 3. So this would mean 7 gets multiplied 3 times, but then the negative just stays out front. All right, on number 4, again, there's no grouping symbol, so only whatever's directly in front of the exponent would be your base. So here the base is 10. Your exponent is 5. So that means I'm going to take 10 times itself 5 times. But there will also be the 3 that was here to start with. That's just going to get included right there. All right, number 5. Again, no grouping symbol. So I think it helps if there are no grouping symbols, put whatever is directly in front of the exponent in parentheses. So here my base is not the entire expression. It's just the y. The exponent is 2. And if we expanded this out, only the y gets multiplied by itself, not the entire expression. That looks a lot like number 6, but the difference here is that the entire base is what's in the parentheses. So 4xy is the base. Your exponent is still 2, but the entire base gets written out times itself, which is a little bit different than the one we just did. Okay. So that's kind of just some basic terminology. Make sure you understand what the base versus an exponent is. If there's no grouping symbols, it's just whatever's directly in front of it and it does not include the sign unless they group the sign with it. We're going to actually skip this part here since, I really can't get you feedback in class, so you can leave that part out. So on the next section here, we're going to focus on learning what a zero exponent is and learning what a negative exponent does. So I want to have you think about the way the chart is set up here. I started filling in the chart with the expressions that you can probably evaluate pretty quickly. 2 to the first power is just 2. 2 to the second power would mean 2 times 2, which is where I got the 4. 2 to the third power would mean 2 times 2 times 2, which is where we got the 8. So I want you to notice every time we move to the right, it multiplies by 2. 2 times 4 is 2. 4 times 2 is 8. All right, now, if we work that trend backwards to go from 8 to 4, you're dividing by 2. And again, 4 to 2, you're dividing by 2. If I divide this by 2, I get 1. If I divide that by 2, I get 0.5. If I divide that by 2, I get, think of half of 50 cents, half 0.25. To do that. If I divide that by 2, we get 0.125. All right, now, that's pretty easy to see the pattern. What I want to do now is write them as fractions. So 1 as a fraction is just 1 over 1. We'll continue off to the right. 2 over 1, 4 over 1, 5 over 1. Oh, I'm sorry. Not 5 over 1. 8 over 1. There we go. All right, now, going the other direction, 0.5 would be the same as 1/2. 0.25 would be 1/4. And 0.125 is actually 1/8. So this is what I want you to notice. 1 over 8 is what we got for 2 to the negative 3. Compare that from 2 to the third, which is just 8. Basically the same answer, but flipped. Okay, compare that on the next set. 2 to the negative 2 power gave me 1 over 4. 2 to the second power gave me 4. Notice it just flipped. One more pattern. 2 to the negative 1 gave me 1/2. 2 to the first gave me 2. So the only difference between these answers is the negative exponent. So that has to mean that a negative exponent means that whatever we started with, we're just going to evaluate the exponent and then take the reciprocal. It's literally, that's all a negative exponent does. So a negative exponent means that you still evaluate the power then you take the reciprocal. So it's almost like you pretend it's not there and then just flip your answer over when you're done. So like 2 to the 5th is 32. 2 to the negative 5th is just 1 over 32. It literally just flips it over. Okay? The other thing that's not quite so obvious is this middle column here. Since the exponent was 0, the 0 exponent always gives you an answer of 1 to whatever base that it applies to. All right, guys, that's all you have to do for right now. Read the rest of the post, and I'll give you directions on how to submit your work for today. I divide that by 2. Whoops.